Check, check, check. Okay. Good morning, everyone.
Good morning.
How you doing?
Excellent.
Good. It's so great to be here at Scala Days this year. I'm really loving it. Awesome keynote this morning. We're going to be talking about the cake pattern today, which is a way of doing dependency injection. So I'm going to start off with a bit of an introduction to dependency injection, talk about how we use the cake pattern to implement dependency injection, look at some of the problems with the cake pattern and how we might address these, and I'd like to finish up talking about some of the advantages of using cake pattern over other forms of dependency injection. So, what is dependency injection? Well, what we're really trying to do is decouple the process of obtaining our dependencies from the code that is using them. And this really makes it a lot easier for us to unit test because we can sub in mock objects or stub objects for our dependencies when we test. And more generally, it allows us to create different configurations for our application by providing alternative implementations for some of the services in our application. So this is really about separating API from implementation. And to sort of describe this, I'd like to bring up this image from Martin Fowler blog post. It's about 9 years old, so it's a little outdated, but it's a great article just the same. And it gives you the basic background of what's going on in dependency injection. And in this graphic, I sort of imagine a conversation between two developers. And the first developer says, look, I've totally separated my movie lister from my movie finder. Every time the movie lister goes to use the movie finder, it's using the API, it's using the interface, and not the implementation. And then the second developer says, oh yeah, except right down here, where you're pulling a specific implementation out of the movie finder out of a singleton object. So you really did the easy part. You just went into your IDE, did a extract interface operation, and you were done. I'm still left with untangling this mess. So let's take a look at how this might appear in pseudocode. This is not pseudocode yet, but I'm just going to sort of introduce my running example for the code slides on this talk. Not too big. But so in my application, we have an entity class called a U. In reality, U has about 23 or 24 fields, but I've narrowed it down to 1 just for the sake of this example. And we have a U repository, which is responsible for persisting U's to the database or looking them up. We're just getting started here, so I'm going to just have a single method called getU, which is responsible for looking up retrieving a U from the database. And you can see in this implementation, I'm not actually hitting a database, I'm just returning some U every time. And then down in the middle, where what we have in blue, in our application, we want to test our repository. So we just create a new one and stick it in a val and then test to see what the getU method does. So this is not dependency injection yet. We're getting there. There's actually 2 problems with this code. The first one is this value repository here. Is it going to matter if I move around a lot? Is that going to bother the cameras? All right, I'll try to stay put. The value repository has the wrong type. It's typed to this concrete implementation of the U repository. We really want it to be typed to an API. This is like the first step that we need to take in order to provide different implementations besides this default implementation. So let's address that problem first. And what I'm going to do is replace this single trait U repository with 2. The first one is the API, and the second one is the Impl. The first one reproduces the signatures for the method, but the method getU is abstract. There's no method body there. And that we get that in our default implementation. So great. So now I can type my U repository correctly. This is it. This is where we got with the first example. The first developer says, "Look, now I'm coding all against the API." And this example is just one simple line of the U repository called getU. So that's an improvement. Now, before I go on, I want to make just a little bit of a generalization, because this process of separating out API and implementation, there's more than one way to do this. It's also kind of verbose. I don't want to repeat this all over the place in my slides. So let's just make a generalization. We're going to replace that API and Impl back to the original version of our trait. And I'm going to introduce this pseudocode on the first line of blue. And I'm just going to say, well, this is the API, and on the left and on the right, I have my default implementation. Still not dependency injection. Well, how do I do the dependency injection? Well, the problem is that inside my application, I'm binding to a specific implementation of your repository. And this is what makes it hard to provide alternate implementations. So I just pulled that out. And you see I pulled it out down to the bottom where I'm actually constructing the application. I'm sorry, it's probably a little hard to see down there. Nothing I can do about that now, though. So the implementation is injected down to the bottom. So now I can introduce a piece of terminology which I just made up for the purpose of this talk, I think, which I'm going to call the injection site. So the U repository val we're using here is the injection site. This is, well, the application has a dependency on a U repository. At some point, the dependency is going to be provided to the application. And where that it gets provided, we're going to call the injection site. So right here, I'm using just the val. There are other ways that this could happen, and just in general, I want to abstract that. So we're going to call something that has an injection site a component. To override a term that has a lot of different subtle meanings. But I'm going to call this a component. So the component API of a U repository is something that has an injection site for a U repository. But that injection site is abstract. It's not defined. It's not instantiated yet. Down at the bottom, I have the component impl of the U repository. And here I get a concrete implementation. Again, the default implementation of the U repository I have up at the top. So let's expand this example a bit, make it a little more realistic. I have an S repository and a T repository, which are suspiciously similar to the U repository, but let's see. Now when we assemble our application, we're going to stick in a few different repositories. This is basically the same example. You're still going to get output from the default implementations. It's just kind of messy, because I'm repeating 3 components all over the place here. And this is not going to do, because real applications have a lot more than 3 components. And there are going to be other places where we're going to have to repeat this too. So let's introduce a new concept. And I'm going to call this a context, sort of a shout out to Spring, which I used many years very happily. They call these things an application context. It's just a place where I'm going to put all my my components. So the context has these parts. It has an S repository, it has a T repository, and it has a U repository. What this means is that the context as a component is going to have 3 injection sites. So the S repository has 1 injection site, the T repository has 1, the U repository has 1. I have 3. So that's that just gets rid of a lot of code duplication there. Let's talk about components with dependencies, because it isn't just your main application class that is going to reference the services you want to provide in your application. Services have dependencies on each other. So here the use service, which is designed to sort of handle business logic involved with the U entities. It sometimes needs to delegate to the database, to the U repository, to look up U's or persystem or whatever. So I'm going to declare a dependency on the U repository, and then I'm going to have a getU method with a very similar signature, and it's just going to delegate to the U repository. So what this has dependency means is, well, by the time I'm in a component and inside an application, I'm going to have been provided this U repository injection. So right now I can use it. I'm abstract, but I can use it. So in my context, I'm going to extend my context to have 3 more services inside of it. And now when I run the component, this application example is the same as before, except I'm testing the services now instead of the repositories. I get the expected output. Up at the top, the services are abstract. At the bottom with the component impl, they're given the default implementations. And that's the point where the U services dependency on the U repository is satisfied, because the component implementation puts them all together. So that's a great start, but we want to deal with component substitution, which was the motivation for this whole business. So I have an alternative version of the U repository. This one, the getU returns a none instead of a sum. And what I wanted to say in my dependency injection language, I'm going to use the pseudocode stands in for. By the way, I think I forgot to say, like, everything I'm putting in blue here is my pseudocode for describing what we want to do for dependency injection. It's not real Scala code yet. So I want to say that the alt U repository plays the same role as a U repository. Or in other words, well, you know, the S service has a dependency on a repository. I should be able to put an S service with an alt U repository and have things work. So it's standing in for a U repository. I have to do the same thing with the context. The context is a stand-in. The alternative context is a stand-in for the normal context. And here I could list out that it has parts. It has an S repository, it has a T repository, it has an alt U repository, etc. But I'm going to take a quick little shortcut here, which is the commonly used trick, which is I'm just going to say, well, I'm basically the same as the context, but I'm going to override this one part. The U repository is going to get overridden by the alt U repository. So now when I instantiate the same application with the component implementation of the alternative context, I get the different output. And you can see there at the end, I get the none from the U service, actually. Mocking components is sort of the same idea. And I'm going to write a spec for my U service class that I'm going to do expectation-based testing. So I want a mock object for my dependency. I want a mock U repository, and I want the default implementation of my U service. So I'm going to put up some pseudocode here for U repository, a mock version of that, and the implementation of the U service. And in my test, I can call the U repository and get the mock, and I can call the service and get the real thing. So how do we do this using the cake pattern? Well, the basic idea is very simple. Let me get started with a preliminary here. I'm going to do the same thing as before. I'm going to separate out the API and the implementation for the U repository. This is the same code as before. We're really going to be using very basic Scala type constructs to construct these dependency injection features. And the basic idea is that we want to wrap the type and the injection site inside the same component. So you can see that's what I'm doing right up at the top line. I'm defining my trait as the uRepository API, and right next to it, I'm putting the injection site. Down at the bottom, I'm going to have a component, the default implementation of that, which instantiates the value at that injection site with the default implementation. So how do we do dependencies in cake pattern? So as you remember, the use service needs to get its hands on a uRepository, and it needs to be pretty agnostic about how it does that. And what we're going to use to do that is a Scala language feature called a self-type, which you can see here in bold. And basically, as I understand it, what a self-type is saying, well, by the time this use service component impl is instantiated, it's also going to be a uRepository component impl. So that means, even though I'm abstract right now, I know by the time that I'm concrete and instantiated, I'm going to be a uRepository component impl, which means I'm going to have a uRepository injection site, and it's not going to be abstract, it's going to be concrete, because, well, I've been instantiated, so I don't have any abstract members left. That's the basic idea. We still have to assemble a container. So in this case, in my context, I want to have two injection sites. I want to have an injection site for a uRepository and an injection site for a uService. So the uRepository component has an injection site for a uRepository. So if I extend that, I get that same injection site. And the uRepository service is the same thing. Each of the things I'm extending have one injection site. Now I have two. So when I assemble the application, I get the expected output. Again, my application class is abstract because I'm just hitting the API of my component, which provides abstract versions of these injection sites. Down at the bottom, it becomes concrete because I put in the default implementations of my services at those injection sites. So component substitution is sort of the same idea. I want to, well, I have an alternative version of my repository, but the component wants to put it at the same injection site as the thing that it's standing in for. So you'll see there the lazy val uRepository in green is just going to provide an alternative version of the repository at the injection site. I'm going to use the same trick when I build up my alt context. I'm going to just override the existing context. I'm going to be the existing context and override this one component. And then when I assemble the application with my alt context, I get the alternative output. Mocking components is basically the same idea. I want to provide a mock object at the injection site for the repository. And then I can go ahead in my spec. I can extend the repository as a mock, and I can extend the default, I can get the default uService component, and I can test my uService against a mock object. So let's talk about some of the cake patterns of some of the problems that we have with the cake pattern. It's confusing. There's a lot, it's hard to understand. because we're not using a library that just tells us what's going on. We're using these underlying language structures in Scala and they're not really signifying our intent. And as well as that, there's a lot of boilerplate. And when you do get errors, the error messages are also confusing because the error messages are going to address the underlying language features you're using and not your intent. So let's take a look at the boilerplate. This is the same slide I showed as before, except I put in red everything that doesn't matter. I'm a U repository. I have this signature, and this is my default implementation, right? The rest of it is noise. It actually gets worse like this if you're like me and you feel compelled to write Scala.comments on everything that's public. I have 8 Scala.comments here, 6 of which are basically copies of the other 2. So that's really, that's sort of a smell like if my comments, if I'm putting a Scala.comment on 2 different things and there's like 2 words different in them, then I'm repeating myself, not just in the comment. So what are we going to do about this? We're going to address some of these problems we have with the cake pattern using type macros. So if you went to the last talk, you might have heard more about this, but the type macros, what a type macro is it's a function that runs at compile time in order to create new types. And the type macros functions can have all different kinds of parameters, including type parameters. So when we can inspect the underlying type in our macro, say we get a type parameter that's a U repository, and then we can generate a new type based on the contents of that underlying type. So we're going to implement the pseudocode that I presented in the first set of slides using type macros. Here's a short list of the macros that we could write to do this. I'm good on time, so I'll go into a little bit of some of these. What is the API going to look like? In these slides, I'm going to have this green code that's sort of going to, it's also, again, it's pseudocode. It's going to show how the macros are going to expand. So what does the API of a U repository look like? Well, just what you think. The macro is going to iterate over all the methods and maybe the vals in the signature of the U repository and provide the same method signatures, but just make everything abstract. And then the default implementation, which again is down low, is hard to see, but the important thing about the implementation is, well, I have to extend the API or it's no use to anybody. And then, as a little trick, I can just use the U repository itself to fulfill that API and put the real method in there. So in short, the API says I have a getU method. It's abstract. Okay. Well, so I'm going to extend the API, and then I'm going to extend the U repository as well. Well, look, the getU method that I get from extending U repository has the right type and is concrete. So now I'm a default implementation. Component is pretty straightforward. I just have to provide the injection sites. For the implementation of the component, I'm going to actually instantiate it. For the API of the component, it's going to be abstract. One point, as you can see, in the cake pattern examples, the U repository class was nested inside this trait. So we cannot do that anymore because now the user is writing the U repository class, and the components are getting generated after the fact by the type macros. So there's a few more. I meant to black out number 8. So 6 through 7, I'm not going to go into the details at this point, but they're basically going to influence how the component macros will expand. So for instance, if I have a has part, sorry, I said I wasn't going to go into the details. So we're solving problems here. We've removed all the boilerplate. We have the simple syntax of just these method calls that just take one type parameter. We're also signifying our intent. We replaced the boilerplate, which was using these generalized language features, with method names that are meaningful. In principle, I think I totally skipped that part on this slide. Where was it? Here. Oh yeah, I did mention the error messages. The error messages are really confusing, and we'll see an example of that. In the principle, the type macro could preempt the standard error message and produce more meaningful errors, but I haven't really had a chance to investigate that yet. So this is proof of concept. These work. I have most of the macros I've shown here implemented, except for the last one, mock. I have a version that works for easy mock that I just still need to generalize. You can check out the source code on GitHub. If you do, I recommend you start at the Congeal Examples project, which will flesh out examples similar to the ones I'm showing in these slides. I have 7 example cases. They all compile 31 tests. The caveat is that I'm using this experimental version of Scala to do this, which means probably nobody is really going to use it. Yeah. But I'm very optimistic that I'm going to be able to get a version of this running against 2.11, which, as I understand it, is supposed to be out by the end of the year. Roughly. I don't know the details of that. So this is a proof of concept. There's a lot of limitations. I've put some requirements on what kinds of things, what kinds of types these type macros will accept as their arguments. I say it has to be a trait. I could easily accept classes with no arg constructors. And it has to be a static, a static type, which means it's not a path-dependent type. Maybe there's some way to reason about this to make it make sense, but I really haven't thought about it much yet because I just wanted to get this working. And number 3 and 4, if there's time at the end, I can go into a little detail, but basically for my own sanity, the macros that I've written only have to look at the signatures of the types. Now, if I wanted to handle writing an impl class that's say list, well, there's methods in list that at least one place in the list class that creates a list. So if I wanted to write an impl of a list, I would have to rewrite that code to return an impl of a list instead of just the list. And I'm not going to go there yet. Maybe never. So I'd love to relax those constraints on the underlying types. I'm really a little lagging on providing good documentation. There is some, but I want to write a good getting started doc. I'd like to make the existing macros more robust. I'm kind of doing test-driven development, so I have 38 test cases, and they're all in my style. So as soon as anyone else starts using it, I'm sure they're going to give me some interesting work to do. And eventually, I'd like to be able to look at making the error messages more friendly. And again, we'll get to see an example of that in a minute. I would like to spend some time on some of the advantages of using the cake pattern, because it's really cool. I mean, it's really weird. It's hard to grasp. If you're used to just using a framework to give you dependency injection, and now you're writing these loads of boilerplate using these, Self-types are not necessarily the most obvious typing feature to someone coming from something like Scala. But there are some really cool things about it. First of all, it's type safe. And this is something that's important important. It's important to me. It's probably important to most people at this conference. If you go back and look at that Fowler paper, or if you consider Spring, or if you consider Juice, they all depend to some degree or another on runtime configuration. So if there's a missing dependency, you find out when you try to run the program. With the cake pattern, you find out at compile time. It's going to error, because at some point you're going to try to instantiate something that still has an abstract member. This is really cool. So, the dynamic typers are fond of saying, well, if the compiler doesn't catch it, I can just write a unit test for it. Well, here's one situation where that doesn't work too well, because I cannot write a unit test or a test for my production configuration. I can't test my production configuration until I release it to production. So it's good. I mean, there are things that we can do. We can stage it, whatever. But it's good that we can get more assurance early that our production configuration is consistent. The second thing I'd like to talk about is the underlying type structures we're using are really flexible. We're basically using inheritance and self-types. These allow us to really get expressive in how we create components. And I'd like to show you an example of that. In the earlier example, we had this context, which had these 6 sub-parts to it. And what you realize is, well, there's no reason why we can't use inheritance and self-typing on this context itself. And then it sort of dawns on you that this context isn't really a context. It's really a root of a tree. It's a very flat tree at the moment, but we can split it out. So here I've put in some internal nodes to this tree, one for the repository, which has parts for all the repositories, and one for the service, which has the service parts. Down at the bottom, again, I'm sorry if you can't see, but I've renamed the context to root, and it has 2 parts. One is repository and one is service. And this is almost exactly the same as the previous example, but there's one critical difference. And that's what I have bolded there in the middle. I'm declaring the service has a dependency on the repository. Now, if I leave this out, I get an error message that looks something like this. Illegal inheritance. Self-type service component impl does not conform to use service component impl self-type. If you're a newbie to Scala, this is not fun. But let's try to work out what it's actually trying to tell us. So again, as a thought experiment, I've left out the has dependency line there. So now the U service, as we remember, has a dependency on the U repository. What this means is that as a component, the U service has a self-type on the U repository component. So the U service component has a self-type on the U repository component. This means that, by the time the U service is instantiated, the U service component is instantiated, it's also going to be a U repository component. So the U service is saying, well, if this service guy wants to extend me, it has to obey my self-type. Or there's 2 ways that it can do that. It can either repeat the self-type, or it can extend the U repository, essentially satisfying that dependency. So that's exactly what service does here when it declares a dependency on the repository. It's saying, because the repository component is a U repository component, it satisfies that self-type. So, and that's a key difference that allows us to, first of all, this error message I'd love to be able to replace it with something like, instead of saying illegal inheritance, it's an unsatisfied dependency. The service has to declare your repository as a part or a dependency in order to satisfy uService's demands. But this is really a striking change. It allows us to do application design constraints. And I'm showing an example here, which is sort of a standard pattern on the server side if you're doing a web application, or at least maybe 5 years ago. I don't know if this pattern probably is starting to break down nowadays, but you know, here what we're doing is we can design our application like this. Now, if we're using something like Spring, everything is going into this flat namespace. There's nothing preventing, say, a repository from injecting a service into itself. Now, we all know this is sort of, you're not supposed to do that, but it's not being prevented. So but with the cake pattern, we can enforce this at compile time. So we can enforce the one-way relationship between services and repositories, as I've shown in the previous example. We can do the same thing for a GUI application if we're doing, say, MVC on the desktop. You know, MVC is pretty much all about who can see who. So let's enforce this at compile time. Let's make these constraints part of our application instead of just drawing on some pattern that, as we all understand it, because it's it's pretty standard analysis pattern in the field. And these two examples might be slightly misleading because we are talking in these examples about standard analysis pattern, but this should apply to your app. You know, every application is unique and it should have its own unique structure. So what happens in real life? The architect or whoever initially writes the program will describe that design in a doc, and then to be friendly, let's say, a year later, let's say 5 developers have joined the team, and to be nice, we're going to assume, well, they've all read the doc once, but do they remember it? And what does the doc evolve as the application evolves, as the application design needs to change? And pretty soon you're just going to have a developer breaking your design constraints. Let's talk about another example, which is hidden dependencies. In this example, I have a letter factory, which creates letters. There's also these 3 other factories around, an S factory and a T factory and a U factory. And the letter factory just sort of delegates to these factories to do its job. So I have 4 services that I'm going to stick in my namespace. The important thing here is like, well, this S factory, let's take the U factory. The U factory is really written it's there for the use of the letter factory. Right? No, if I was a U repository, I shouldn't be hitting the S factory or whatever. These are we want them to be hidden. We want them to only be available to the letter factory. You basically cannot do this in Spring or Juice. But it's really easy to do with the cake pattern. All you have to do is leave those hidden components out of the API. They're inside the Impl, and the Impl gets 4 factories, but the API only gets the top one. So now nobody outside of the factory is ever going to see those. Here's another example. Let's say we're doing CQRS and we want to sort of separate out the read side of our model from the write side of our model. But the model may evolve over time so that these 2 sides diverge. But for the time being, they're both being backed by the same var that I've underlined that I've put in bold here. And this trait down at the bottom, the UI model, provides implementations for the get-u option in the read-only model, and it provides a set-u option for the write-only model. It stands in for these two models. So I have one implementation with two APIs. And then when I go ahead and build my UI view, I can do the right thing and say, well, the UI view can only use the read side of the model. And this is no longer just the right word's not coming from me. But it's not, this is now enforced by the compiler. You can put this in your design. Well, in most cases, there might be a rule, there might be a document on your project that says, oh, you can't hit the read side of the model. But here it's real. It's compile time. And then I'll show, this is basically pretty straightforward. Nothing much to show here. Is that I can hit the read side, I can hit the write side, and it's hitting the same underlying var. Thanks for coming. I know this is a lot of information. There's also a lot I left out. But it's all, you can look for it on my blog. First link is a static page on my blog where I've collected a variety of resources about the cake pattern. The second, this is the project I have where I implement these macros. And feel free to send me an email. I'd like to give special thanks to everyone at the Broad Institute where I work for their support, particularly my team and my wonderful boss, Tom Green, who's there in the audience. Thanks, Tom. That's it. I have a few minutes for questions.
This stuff looks really cool.
Thank you.
In the last talk, though, we learned that type annotations
Yes.
are getting into Scala 2.11.
That's right.
So have you tried this out with, I guess there's annotation macros?
I have not tried the macro annotations yet, but that I intend to do so in order to get this out the door. I like the type macro syntax a lot better, but that's, whatever. I'd rather have people using it.
Yeah.
So.
Do you think it'll still look right with the...
Yeah, so I could go to any example. Oh, whoops, I'm in a different view now. Let's find an example. Like this one, just taking an example at random. I better make that big. I'm sorry, I'm not really tremendous with this application. So this would be, instead of extends, has part, s repository, whatever, it would be those, and I don't actually know this, but this is what I imagine. It would be above trait u repository, I would say @ has part s repository, @ has part t repository, like that. So syntactically, it's not any more verbose or anything, but in my mind anyways, these things make sense as types. But we'll live with it. And then when type macros come out, if and when they do, I'll change it back. And I'll probably be forced to support the macro annotations after that. Yes?
Can you deal with the situation where you have two members, like a service using two repositories, same interface, but you want to inject two different implementations?
Oh yeah, so if you... So what you're saying is, well, I want two different components that sort of have the same type, and I haven't considered that, but I'm sure it's possible. I mean, so I guess what it would take, which is something that I've thought about, is like right now I'm sort of just making up the names for the injection sites based on the class name. So if you were able to specify concretely what you want to name the injection sites, then you could make it work out.
That's more or less how Juice does it too.
Okay. I wish I knew more about Juice. I was Spring forever. You had your hand up earlier.
So you have one API that's being generated out of one implementation. How do you provide a second alternative implementation?
I use the stands in for macro.
Okay.
So if I say the alt U repository stands in for the U repository, then when I call API macro on the alt U repo, it's going to extend the API of the U repo. Yeah, up front.
This was done in a web app environment, right? Looking at your architecture.
It was a client-server app, a fat client.
So you wasn't play or lift?
I was using Lyft on the server, but it's mostly a swing app, but it goes to the server to do REST.
So Lyft has the factory maker. So what Eric was just saying about switching in and out, then you have the factory maker where you can switch stuff.
Uh-huh.
So what I've done in the past is, you see you've got a test. If I'm talking specs 2, we have it around outside, and we can switch our implementations.
Yeah.
By cross-cutting.
Yeah.
So I don't know, did you flip your services
Yeah.
test time with that?
You know, we could talk offline about this, but when I was working with Lyft, I have this problem, which Lyft wants everything as objects. So for some, I don't remember all the details of it, but I did go ahead and define the cake pattern for the server. I defined and then I just have a singleton object because I remember, because like the Lyft classes that I'm using, I couldn't like string them into. The control of creating them is controlled by Lyft, so I can't put them into my cake. So I just give a singleton instance for my cake, and I described that in one of my blog posts. Anything else? Yes.
I'm just curious if you've used Subcut or some of the other Scala.
I've looked at it. I haven't. You know, when I started using cake pattern, this whole thing was sort of an accident. Because, I mean, I was starting a new project and I was looking at what was out there. This was 2.5 years ago. And why don't I try the cake pattern? It's something fresh and new. And then, this all happened. All right, anything else? Thanks for coming, guys. I appreciate it.